All right, today we're going to pull back the curtain on a massive, high-stakes tech upgrade. And no, this isn't about some flashy new app on your phone. This is about the invisible engine that powers millions of critical financial transactions and what it really takes to rebuild it for the future. So let's just dive right in and look at the sheer scale of this challenge.
So let's start with a question to really set the stage here. What kind of digital plumbing do you actually need to handle 1 million student loan payments every single night without a single mistake? The scale is just immense, and honestly, the stakes could not be higher.
1 million. Let that number sink in for a second. That's how many transactions this engine has to process flawlessly, night after night. It's a relentless, high-volume cycle that just never stops.
And who's behind all those transactions? Well, it's nearly 4 million people. 3.8 million active borrower accounts are depending on this system's accuracy. A single glitch can cause a massive ripple effect. The system doesn't just need to be good, it has to be absolutely flawless.
Now, the workhorse chugging along behind this massive operation is a legacy system, older but reliable tech called AutoSys. For years, it's been the clunky little engine that could. But in today's world of AI and the cloud, its limitations are really starting to show. It is definitely time for an upgrade.
So this brings us right to the core conflict, what is basically a tale of two engines. On one side, you've got the legacy system, AutoSys, with all its complex, code-heavy scripting and, frankly, an outdated interface. And on the other side, the promise of a modern AI-powered system that's intuitive and can connect to pretty much anything. The choice seems obvious, right? But the path to get there, well, that's incredibly complex.
So how do you even begin to pick the right replacement? Well, that brings us to what's essentially a tech bake-off. It's time to meet the top contenders, all vying to become the new digital heart of this entire system.
The research really boils it down to a few key players. You've got these established enterprise solutions like Tidal and ActiveBatch, which, they promise a pretty smooth transition and really robust support. And then you have these powerful open source platforms like Apache Airflow, which offers incredible flexibility, but it's going to require a lot more in-house expertise. Each one of these represents a totally different philosophy for solving the same problem.
And when you break down the choices, it's actually fascinating. You see, Tidal really excels with tools that are specifically designed to migrate from the old system, AutoSys. ActiveBatch, on the other hand, it shines with its native support for the existing Windows and Oracle environment. And then there's Airflow, the powerhouse for custom code-driven workflows. You see, there's no single best here. It's all about trade-offs.
So, how do you judge this contest? I mean, it's not just about who has the coolest features, right? The decision is really governed by a strict set of business and technical requirements that the new engine absolutely, positively has to meet.
These are the non-negotiables. First off, can it handle that massive scale we talked about? Second, does it play nicely with the existing infrastructure, the Windows servers, the Oracle databases? Third, and this is a big one, how quickly and painlessly can you actually migrate from the old system? And finally, is it a platform for the future? Is it ready for the coming AI revolution?
And then, of course, there's the money. A hard, non-negotiable annual cap of $2.8 million. This constraint forces a really sharp focus on the total cost of ownership, from licensing all the way to long-term support.
And as if the stakes weren't already high enough, the proposed timeline is just incredibly aggressive. A 1-month modified sprint migration. Let that sink in. The entire transition, from setup and conversion to testing and the final switch, has to happen in just 4 weeks. This makes the ease and speed of that migration an absolutely critical, high-pressure factor.
But here's the thing. This upgrade isn't just about replacing an old part. It's about building a foundation for the future, a truly intelligent AI-driven system. And this is where it gets really exciting.
The vision here is really ambitious. The goal is to implement what the source material actually calls ultra-wise AI agents. And we're not talking about simple bots here. These are sophisticated AIs designed to analyze, predict, and act all on their own to keep the system running perfectly.
This is the whole concept of autonomous operations. So imagine a system that doesn't just send an alert when something breaks. Imagine a system that sees the problem coming, analyzes the root cause, and then fixes it automatically, often without any human needing to step in at all. That is the end game. So, what does this actually look like in practice?
Well, a day in the life of an AI agent might go something like this. It senses a subtle, unusual error pattern in the system logs. Then it analyzes that against all the historical data and predicts that a critical process is probably going to fail in a few hours. And then it proactively alerts a human operator with a very specific warning and even a recommended fix.
And believe it or not, it gets even more advanced. The agent-to-agent protocol is basically a framework that allows different, specialized AIs to work together. Think of it like a team of experts. One agent that's great at analyzing logs finds a problem, it passes its findings to a failure prediction agent, which then might consult a schedule optimization agent to find the best solution. They're literally collaborating.
So that's the big question, right? How do these agents get smarter over time? Well, that's where something called the Model Context Protocol comes in. This is essentially a long-term memory for the system. It lets the AI remember every issue it's ever seen, learn from the outcomes, and then use that knowledge to make better decisions next time. It doesn't just solve problems, it learns from them.
All right, so after weighing all the criteria, the budget, that crazy timeline, and this incredible potential of AI, how do you make the final call? Who wins the bake-off? And here it is. This is maybe the most important lesson in this whole thing. In the world of high-stakes enterprise technology, there's almost never a single best answer. The right choice is always a strategic one, based entirely on an organization's very specific priorities.
So the final decision really just becomes a strategic trade-off. If your number one absolute biggest fear is that risky one-month migration, you're probably going to lean towards Tidal. But if your top priority is a perfect, seamless fit with your existing tech stack, well, ActiveBatch is the logical choice. And if you value long-term flexibility and customization above everything else, you go with Airflow. Ultimately, the specific tool that gets chosen is almost less important than the process itself. The real takeaway from this deep dive is understanding the incredibly complex and careful decision-making that goes into modernizing the invisible, critical infrastructure that we all rely on every single day without even thinking about it.
And that kind of leaves us with a final thought to chew on. From banking and healthcare to the power grid, our world is just full of these invisible engines. So what systems in your life, the ones you depend on but never really think about, are ready for their own AI-powered revolution?